Well, thank you everyone for joining us. This is our second official Engineering and Life presentation. These presentations are opportunities for working engineers to talk about their careers or their paths up to their current career. We hope that you all will continue to join us in future presentations and that you enjoy the presentation we'll be giving tonight or this morning, depending on your location in the world. If you have any questions at any time, you can type them into the large meeting room chat and we'll open up a Q&A at the end of the presentation. This session is being recorded and a link will be shared in our announcements channel when we post the video online. Everyone is welcome to share their story. If you think you might like to give a presentation yourself, you can message myself or anyone with the event coordinator role, such as Ada or Jack. If you enjoy the presentation or learn anything new, we ask that you share our Discord link, which you can find in the large meeting room chat. With that all being said, again, I invite you all to ask your questions as we go along. And Laz, if you would like to start your presentation.
Yeah. Well, good morning or good evening if you're American. I'm Laz. I'm a mechanical engineer. With about 9 years industry experience. About 5 of that is in design. I'm going to be walking through kind of my career so far. It'll be I'd say about 30 minutes long is what I'm going to aim for. I don't really have it planned, so it's going to be a bit free form. Just bear with me. And then at the end, we'll do questions, and I don't have anything to do today, so I can answer questions for basically as long as you like. So I just want to point out, I like this little icon here. You see it on a lot of engineering presentations, and it's a running joke in my industry because this wouldn't turn. You can't have 3 gears in contact. So this is stupid, but I still love it. All right, so when I was doing my presentation, when I was writing the slides, I was originally going to just talk about my career, but I realized that I work in an industry that has a lot of contact with other industries. I see, all kinds of different applications for our products. We just have a very versatile product, which basically every industry needs. So I thought it might be useful to talk about those industries, about all the different places that exist. It's pretty common for new grads to not really know what industries they can even work in. Like a lot of people think that you have to go off and you got to work for those big, huge, defense corporations, or Raytheon or Boeing, but you actually don't. There are thousands of tiny companies, ranging from 10 employees all the way to 50,000 employees, and they all need mechanical engineers. It's a really, really broad field. So I hope that by talking about my own career, that you'll get a better feel of what industry is like, how broad it is, and where you can look for jobs. Cold calling specific OEMs that you that you might like their products or something. Oh, by the way, OEM is original equipment manufacturer. In case you don't know, I'm going to try and keep the jargon to a minimum, but it's hard to do that when you're an engineer. Jargons are our way of life. All right, so a bit of background about me. I'm from Ireland. I went to university in Dublin, which is right here, this little tiny island off the coast of Europe. I graduated with a Bachelor of Engineering in Mechanical Engineering. I graduated in the top 1% of my class. I was actually ranked second out of, I don't know, a lot, which is good, I suppose. A lot of people aim for high marks. My personal opinion is that aiming for high marks is a complete waste of time. You'd be better off just getting a pass and just having fun in uni. Like, really, nobody cares what mark you get in uni once you're in industry for about 2 years. So don't kill yourself getting good marks. That's you'd be better off just kind of building others kind of soft skills while you're in uni. So I graduated in the middle of the global financial crisis back in 2011. And it was an absolutely awful time for my country. unemployment skyrocketed up to about 25% or so. This picture here, this is a picture of one of the main office districts, and you can just see all the signs for the offices to rent. The whole city looked like this. There was like no jobs at all. So I started looking around the world and places that I could go that maybe I might be able to get some jobs. I went to the UK for a little while, didn't really like it. And I eventually decided that I would go to Perth in Western Australia, which is all the way over here, which is a big move, but it ended up being probably my best career choice that I ever made. So you might ask, why the hell did I choose Perth in Western Australia? Because honestly, who's ever heard of that city? When I was looking around for things, I was looking for places where maybe where there'd be a surplus of jobs, where I'd be able to go. And there wasn't a lot of places in the world that were like that at the time. It was really between Canada or Australia. I kind of just flipped a coin between those two countries. So I just got on a flight and I just went. I had no plan. I didn't know anybody there. I didn't have a job lined up. I just got on a plane and I just tried my luck. The reason I went there is Australia was going through kind of a mining boom at the time. Australia produces absolutely ungodly amounts of commodities export, and minerals and wheat and beef and things like that. Iron ore is the biggest export in Western Australia by far. About 37% of all global iron ore comes from Western Australia. They're also the biggest producer of bauxite, second largest producers of coal, and pretty much anything you can think of, it's mined there. Copper, uranium, and even all like the weird stuff, nickel, cobalt, vanadium, chromium, molybdenum. All that stuff is all mined in huge quantities in Western Australia. So there's a lot of jobs in mining, and there's also a lot of jobs in the industries that support the mining industry. Here, this is a picture of a train. This is an iron ore train. It's kind of hard to see, but that train goes all the way off into the distance. To just give you an idea of how much iron ore, and there'll be hundreds of these trains every single day leaving Australia. So when I got there, I kind of started looking for a job, and I got really lucky. And within 3 days, I got a job with a company called Bulk. They make gearboxes and gears in general. They're probably the biggest gear company in the United States and one of the biggest in the world. They've lost a lot of market share in recent years, but they're still a pretty big player. And especially in kind of, the post-war years, they were hugely influential in in gear design. A lot of the gear standards that people use globally were written by these guys, so they were pretty influential in them. In Perth, they had an absolutely tiny office. I was one of 4 people and one of 2 engineers who worked there. And I was working as internal sales. And I'll talk about what internal sales is in a little bit. It's a job that's really common for engineers to go into, but it's not one that's like very well known. This here is probably their kind of bread and butter. This is their standard catalog product. This is just a gearbox. I'll go in a little bit more about what these are and what they're used for, but to give an idea of size, this one here is probably about 1.8 meters tall. They also do ring gears like this, which can be obviously really big. And this was a big part of their business for a long time. So internal sales, it's a super common job for new grads. In my opinion, it's a pretty good one, but it's not very glamorous. Essentially, a customer will come to your company and say, I need a machine that can do X, Y, and Z. And an internal salesperson will look through the catalog, find the right product, or maybe modify an existing product, and then give the customer, price it up and give the customer a quote. It's frequently, these internal salespeople are engineers, because you need to do a lot of calculations. Some customers have specific specifications that they need you to comply to. Some applications can be quite weird and unusual, and you need to do some background work to make it work before you can actually hand it off to the design team. So internal sales forms the link between the customer and the engineering design team. The internal sales guy will write the design brief that the design team will use to design the products. It can be exceptionally technical. You can be doing like a lot of math and a lot of hard design in SolidWorks, or it can be incredibly basic. You can just be looking up catalogs and just choosing products straight out of there. It's kind of depends on the company. I think it's a great job to start off with because you'll get exposure to every aspect of that company's product and their portfolio. You'll see everything that they do from start to finish. And so you get a really nice all-round experience, but you don't get any very specific experience. So that's the downside of it. It's good if you're the kind of person who likes talking at work. If you don't really want to be sitting at a desk all day just clicking screens, internal sales is pretty good. It can involve a lot of travel. A lot of times you have to go to customer sites to look at their applications, to look at the kind of things they need to do, to understand what it is they need. I spent a huge amount of time traveling around different mine sites in Australia. I probably spent more time on site than I actually did in the office. So yeah, it's a good job. It's not what people have in mind when they do engineering in university, I think, but it's a great place to start if you can't get your dream job straight out of uni. So after I did this for Falk, for personal reasons, I had to go back to Ireland, and I got a job with this company here called Prodico. Now, Ireland's a small country, and there's really, for mechanical engineers, there's really only two industries. There's pharmaceuticals and semiconductors. The pharmaceutical industry is absolutely enormous. I can't remember the exact percentage, but I think it's like 30% of Ireland's economy. So if you're a mechanical engineer, you're probably going to work in pharmaceuticals. This company here, they are a tool maker. I'll explain what that is in a little bit more detail. A lot of people don't even know that this exists as an industry, but it's super, super important. And there's a lot of job opportunities with tool makers. This company was kind of small to medium. I think there's maybe about 100, 120 employees, about 30 to 40 engineers. I'm not sure that's exactly right, but it's roughly right. And they specialized in tooling for manufacturing blister packs, which are these things here. We've all seen them. You've probably never thought about how they're made, but I spent a huge amount of time thinking about how they're made. It's an incredibly specific niche, but there's a lot of these little tiny niche companies out there that do kind of things that you don't expect. This is the manufacturing floor here. These are just a whole bunch of CNC mills. In the foreground, you can't see them, but they had a whole bunch of grinders, about the same numbers as this. And then behind that, they had a whole bunch of wire EDMs. But the whole thing could fit inside a small warehouse. I started off there in internal sales again. But as I was in this role, I moved them away from sales and more into design, and specifically into machine audits and tooling design. These are the products that they make down at the bottom here. So they just kind of look like random machinery components, but these are incredibly precise machines. Any tools need to be made with an absolutely absurd level of precision, which made this pretty challenging and kind of fun job. I quite liked it a lot. So I'll talk about what a tool is and what a tool maker does. When you buy a machine that manufactures something, say, something that manufactures, say, glass bottles, right? The machine itself is capable of doing a lot of different types of glass bottles. If you look at videos, of like how they're made and like, just assembly lines in general, just making things, you'll see that the machines are making a specific part, but the machine doesn't have to make a specific part. It can make almost anything, within that, any type of that product. And the way that you change it to make different things is through the use of tools. And these are examples of tools down here. And then this one here is just a picture I got off the internet. It just picks up as like an item and moves it onto another thing. You see it has some like little jaws here that grab it, and it picks it up, and it's only able to pick up that one thing. That's all it can do. It can't do anything else. So they have to be made bespoke for every product that you do. So each tool that you make is custom to that product. This here is a blister pack machine. So this is a machine that actually packages pills, puts them in a blister pack. This is a German machine. And inside here is a whole bunch of tools that can make specific things. So you see in this video here, an idea of what a tool is. So this tool punches out the blister packs from the web. And you can see that it's specific to that size of card. It's only able to do that one thing. And so it has to be designed from scratch every single time they change the shape of the blister pack. Even this little sucker arm that comes down and picks it up, that is a tool that needs to be designed from scratch. So this is a huge, huge industry. And if you ever hear companies talking about tooling costs or retooling costs, this is what they mean. They have to change out all the tools in their machines, and it is enormously expensive. This tool here is not that big. It's maybe, 20, 30 centimeters long. But this would cost you about 6,000 to 7,000 euro easily. And then you'd have, a whole set of tools all the way down this machine. And a tooling change out could cost anywhere between 20 to 120,000 euro easily. So after I worked for that company, I went back to Australia. I moved to Melbourne, and I got a job with this company here, SEW. These are a German company, and they're back in the kind of gearing and mechanical power transmission industry. And these guys are massive. If you go to any factory anywhere in the world, I almost guarantee you that you'll see some SEW product somewhere. And they make these things here, gear motors. This is kind of their bread and butter. This is how they got kind of famous. You see here in a picture down here, there's like this is a roof tile factory, I think. I just pulled this from our marketing department, but you can see here there's all these little gear motors down here. And what these do is they just create rotational motion, and that's it. But pretty much any time you see anything moving in a factory, it will be controlled by one of these gear motors. This is a 3-phase asynchronous motor connected to a gearbox, and they're absolutely everywhere. And any movement you see anywhere at all in any industry, you'll have these. This is a picture of the belt drive at Melbourne Airport. So this is the luggage carousel, and you can see that there's like some little drives here. We also make these inverters, which are electrical magic things that drive them. But this is what if you ever wonder what the other side of an airport looks like, well, that's what it looks like. We do everything in Australia from, we supply brick manufacturers, cement. Even one of our biggest customers is they make flight simulators. So they have little motors on them, little gear motors that, move the flight simulator around to simulate to simulate like conditions. So my role in SEW is design and kind of support. So I'm kind of apart from the design team. There's like a core design team there in Australia of about 6 to 8 engineers. I'm set apart from them, so I sit around and do calculations pretty much all day. This is a pic. I just kind of took screen grabs of what my screen looks like at any given day, so you can kind of see what it's like when you work in design. You've always got Outlook open because emails just don't stop ever. I've got some gear design software here, some spreadsheets that I made. These other random spreadsheets that every engineer makes that you just have like, hundreds of these little tiny spreadsheets lying around, and some proprietary software. This here is a design that I was involved with. This is an apron feeder drive. It's a type of conveyor, a really, really big type of conveyor. This one was 600 kilowatts, which is a lot if you don't know about power ratings. To give an idea of size, this from here to here is about the same height as me. So that's about 1.75 meters from there to there. The whole thing weighs 16 tons. And then with the motor, which isn't there, the whole thing weighs about 25 tons. So I'll talk a little bit about the kind of the industries that we serve. Iron ore is probably our biggest single industry. I don't want to put a percentage on it, but I'd say almost around half of the work that I do involves iron ore. It's mostly done in this part of Australia, which is super remote. Like it's about a 2,000 or 3,000 kilometer drive to the nearest city. It's really, really in the middle of nowhere, and it just looks like this. And it's just raw iron everywhere. That's why the dirt is red. It's because there's so much iron in the soil. There's so much iron in these rocks that the rocks will actually take a weld. You can weld a signpost directly to a rock in this region. This is what iron mines look like from the sky. They just strip mine them out. They don't do any like underground mining or anything. They just strip the land bare. This here is a blast. I think this was the biggest blast they did in the last 2 years. That was 11 megatons, so 11 million tons of material they blasted out in one go. So conveyors are probably our bread and butter. This is what I work on probably the most out of anything. Basically, they just move material, from the pit, which is where the material comes from, to the train stations, to where it needs to go. They can be really, really long. You can see this one off here just kind of goes all the way off into the distance, and they can be pretty big. These are ones here that I worked on. You can see here, this is the gearbox here, and this is a 1.25 megawatt, 6,600 volt motor. And mine sites have a lot of conveyors. You can see here, all these here. These are just messes of conveyors, just moving materials around. And they move a almost unbelievable quantity of materials. It's not unusual for a belt to be able to move about 10,000 tons every hour. It's, iron ore is worth about $200 a ton. So it's, you do the math on that. It's $2 million every hour on every conveyor. It's a lot. The power they use is crazy too. This conveyor here, I think, has a total 7.5 megawatt install. To put that into perspective, that's about enough power to supply around 9,000 Australian homes. And that's how much power they're consuming just on the conveyors, let alone the rocks, the crushers, and the other equipment they have. This was a conveyor drive that I did in Papua New Guinea. So this is at a gold mine, which is just in the middle of the jungle. And this was also a pretty big one. The things we do are stackers, reclaimers, and excavators. These are huge machines that we've all probably seen pictures of, but you probably don't know what they do. when the iron comes from the sites, they drop it in these huge big stockpiles, and they stack them in the stockpiles with these stackers. Inside of these, there's a huge drive that pushes the material out. They're also on rails, so they can move up and down the rail track. That needs they need gearboxes too. They need motors. They're also able to slew, so they're able to rotate like on their axis, and they need gearboxes and motors. Each one of these machines is obviously enormously expensive, and they require quite a lot of gearboxes and motors, and it's probably a pretty big part of our business. This here is a stacker at Brockman, which is a Rio Tinto mine in Western Australia, so that's a pretty big one. This is a picture I took of a reclaimer in northern Western Australia at a port facility. So they drop them in these big stockpiles with these stackers, and then when it's ready to go onto the ships, they pick it up with these big buckets here or here, and it moves down the boom down here onto a belt, and then the belts it's loaded onto the ships via these belts. You can see this is the stockyard at I think this is Cape Lambert, which is a port facility. So this is what it just sits here while it waits to go onto ships. The other ones we do are mills, kilns, and dryers, and these are another big part of our business. And this is a mill here. This is used a lot in gold mines and nickel mines, and anywhere where you've got low volume products. So gold typically runs on margins of 4 grams per ton. So for every ton of ore you mine, you get about 4 grams of gold out of it, and that's considered quite high grade. So they need to crush down the rocks, and they need to get the stuff out, and that's done on site on the mines. And this whole thing just rotates, and it gets squished up by these balls, these like metal balls that are inside, and it turns the rocks into a paste, which can then be processed chemically. They have a big gear on the side of them. That's what this is here, and the whole thing is rotated by driving this gear. They can be pretty big. You see one here, and this was made, I think, in Newcastle in New South Wales. And they're using a lot of different things, these types of gears. This is one design that we did. This was for a cement kiln. So cement comes in here and it gets dried and processed, and this turns it here. So this is actually the kiln. So they put cement dust basically inside this, and they just heat it up and rotate it around. This one is at a beer manufacturing plant, actually. This is for drying out malt. So the malt just goes in here, and then it's driven by this gear here, and the whole thing just kind of turns around. Another one is agitators and mixers, and this is another massive part of our industry. This is a aluminium processing plant in WA. You see these. It might be hard to see on your screens, but there's a whole bunch of tanks here. These are precip tanks, and they're just full of water and kind of crushed up iron, aluminium ore. And then they're just put in these tanks and just mixed around while the chemical reaction takes place. So, this plant alone will have a couple of thousand of these, little drives, just driving things. Each one of these tanks down here, these are clarifier tanks. So they serve a different purpose, but a similar operation. So we sell a lot of these to the aluminium industry, to the gold industry, to the food industry as well. As a lot of foods require this. Chemicals and fertilizers require a lot of these too. This is a aerator at a water treatment facility in Melbourne. So this is this supplies, I think, half of Melbourne City's water. So the water comes into these tanks here, and it's stirred basically by these drives, and it just gets oxygen into the water. There are lots of other different types of things that we do here. This is a really big gearbox we did for a hoist at a steel mill. So they just pick up the molten steel and move it around with this gearbox. This gearbox is about the height of a person. To put that in perspective, that whole thing probably weighs around 30 tons or so. These are drives for sugar mills. So this is in northern Queensland in Australia. A lot of sugar is produced there. And they need huge amounts of gear drives, which is not something you kind of expect from an agricultural industry like sugar, but they do purchase a lot of stuff. And these are drives for an escalator. And this is actually taken underneath a train station in the Melbourne Metro. So we're in the process of changing these drives out. These are really old ones, and these are from like the 1970s or something. They're changing them out, and we're just putting in some new ones. But the escalators run over your heads here, and oh yeah, then this one in the middle. This was kind of a weird one. This is one that we did for a meat processing plant. So there are two output shafts here, and they kind of run. They counter rotate relative to each other, and they're connected to these big shafts, and it's used to shred animal carcasses and turn them into mush, which isn't a pleasant process, but it just kind of points out that even food processing and industries where you wouldn't think there's going to be a lot of engineering, there's actually quite a lot of thought that goes into those sorts of processes. This is a shaft. There's no gears in here, actually. This is a shaft for a wind turbine. So the wind turbine blades bolt onto this, and then this part of the shaft here gets inserted into another really big gearbox. This gives you the idea of the size of wind turbines. Wind turbines are another kind of big business for gearbox manufacturers. They're pretty specialized, pretty high tech, and they require really high tolerances and things. So it's an interesting industry. This here is a picture. I don't know why I put it there, but I do failure analysis a lot at work. So I'll get something like this in, and someone will ask me, how did it fail? Why did it fail? And how do we stop it from failing? This is probably, I don't know, 20% of my time is spent doing things like that. I like it, but yeah, it can be a frustrating process, because a lot of the time when you get a failure, the failure itself kind of destroys the evidence. So you're left guessing. So yeah, that's basically it. I think I went a little bit over time, but that's all right. If you've got any questions about it, just type them into that meeting chat, and I'll answer them as I go. It was a little brief, so you might have questions and you might not, but yeah, feel free. All right, thank you.
Yeah, Laz, thank you very much for talking and speaking. You'll see it in the chat as you review over it, but I think we were all very entertained, even if at times we were entertaining ourselves a little more than we should be. But I can start reading some of these questions for you. And again, if anyone wants to ask their own questions, you are welcome to type MQ before your questions. If you've already asked something and you want to get on the mic, you can reply to it and ping me and just put MQ in your message, and we will unmute you so that you can do so. Until then, I'm just going to go in the order that I saw the questions and wrote them down, starting with Emily. Are those excavators or otherwise big equipment assembled on site? And I think that was referring to slide 13 or 14 maybe, where you were showing the large equipment out in Australia, I believe, for the mining industry.
Yeah, they have to be assembled on site. They're far too large to be transported by road or by rail. So even the components themselves can be too large to transport. Like, we had to transport a gearbox up there once, and the entire gearbox had to be taken apart to transport it up there, because it weighed 35 tons and you're only allowed to transport 24 tons by road. Assembling a gearbox is a pretty big job, If we have a look at the slide here, it's kind of hard, yeah, I guess, to get a sense of scale of how big these are. But like that's a car down there, you know, like they're enormous things. They're transported up piece by piece and put together on site. Yeah.
All right. See, Emily also asked, is this second big gear, I think this was on slide 15, the same type as the large gear in the first job?
Yes. So, well, I mean, what you mean type of? They're still gears, right? But do you mean like the same application or different products or?
Application.
Oh, okay. No, it's a different application. So this one here is this is for a gold mill. So this here is a mill. And this is a relatively small one actually. This is called a SAG mill. This is semi-autonomous grinding mills. They can get really, really big. This one I think is around 1 megawatt, and they can go all the way up to about 5 to 8 megawatts. This one on this side I think was I think that was 3 megawatts. So there are loads of different types. You know, the size of them depends on how much power they can transmit. They have different designs too. Like, am I still sharing my screen?
You are. Yes.
I am? Okay. They have different designs. You can see this one here is a spur gear. So there's no, like the teeth are straight. But if you have a look at this one, they're like a little bit at an angle. And that angle means that they can take more loads. But this one is designed clearly for extremely high loads. But this one here is not. This is relatively low load. So we have different designs for different load profiles.
Well, thank you. I think we can jump to Sojourner's question here. What's your favorite type of gear? That seems kind of on topic right now.
That's a good question. It depends. I mean, in terms of like designing gears, I probably like, let me see, where's that picture gone? These ones here. So these are helical gears. I like designing these. I can't really explain why. I think it's because I understand them really, really well, and it's satisfying to design them because of that. So I also quite like bevel gears because they're interesting. I'll actually get a picture of one because didn't put one in there. So like this one. This is a spiral bevel. And these are really, really complicated. You can spend your whole life studying these types of gears and you wouldn't even scratch the surface. So they're an interesting challenge. Most of the time I kind of go by more like what the application is like. I quite enjoyed, working in gold mines, because you don't do it a whole lot. But they pose an interesting challenge when you do have to do them. I hope that answers that.
All right. We're starting to get a lot of really good questions. Just to make sure that we don't forget about the ones that were asked earlier on, I'm going to repeat those out loud. Schrodinger's Turtlebot, what is your favorite thing that you have designed / worked on?
Ooh. Probably the one I enjoyed the most. I don't have a picture of it here, but was working on a conveyor project, and I was involved from like the start to the finish. So I actually quoted the job in the first place to the customer, and then was involved in design all the way through to the completion. And I went on site and commissioned these drives too. So from concept all the way to delivery, I was involved in the process the entire way through, and that was really, really satisfying. I really enjoyed that a lot. That whole process. It was for drives, not these drives, but drives like these ones here. So it probably wasn't like the product itself that made it enjoyable, but more kind of the way that the project ended up, being executed. It was just it's really satisfying when you do a design to see that in the field, and have it, working and moving and stuff, right?
Would you say that could be a good quality to look for in terms of in finding a job? Would it be worth asking an employer, would I regularly be able to see a project from start to finish, such as you've just described?
That is an excellent question that I'd never considered before, but yes, absolutely. If you can see the entire product life cycle, you'll learn so much more than you would by just, designing things, right? Like, you could spend a whole career just like, designing, say, like, what's the best type of thread for this tiny little bolt here? And you'll know a lot about that bolt, but not about a lot of other things. But even if you're not fully involved in the whole design process, just being present for the whole life cycle of the project is hugely beneficial. And it's one of the reasons why I quite like internal sales as like a starting job, because you do tend to see that internal sales, they don't just quote jobs, they don't just do the beginnings of jobs, but they also do troubleshooting. So a customer might come back and they'll say, hey, look, this isn't working the way that we thought, or it's, and then you'll have to deal with warranty claims. And that can also be very educational. So that's, one of the main reasons why I like internal sales is because you do get to see that whole life cycle.
All right. I think that's a wonderful answer. Thank you. Let's see. Hayden asked, did you get any internships in schools? Did you do any co-ops or anything that you think helped you get your first job?
So internships are not as much of a thing in Europe as they are in the US. I mean, from what I've gathered from you guys, it's almost like internships are like pretty much required. Like you just kind of have to do it, and you don't really need to do it in Europe. Some people do. I did not. I just went to university and then I just graduated, and that was that story.
All right. Sojourner earlier also asked, did you ever figure out why that gear failed? I think that was on slide 18.
Yeah. We've not finished figuring out why. I'll make this bigger here. So maybe you can see it. Right. So this is a bevel gear, and it had a crack in it. This is bad. Obviously, you don't want this. It was only in service. Actually, it wasn't in service at all. It cracked during testing. And right now it's at a lab and being destructively tested. So they're like cutting it open and like, testing the material for it. Our suspicion is that it was over hardened. So these are case hardened gears. So the outside of the gear is way, way harder than the inside. Like the outside of it is like glass, but the inside is like super soft, kind of cast iron. And if you harden it too much, it becomes too brittle and it'll start to develop cracks like this. And so that's what we think happened, but we don't have conclusive proof yet.
All right. Well, do keep us informed on that. See, Emily asked, do you do testing of your gears, I guess, before they go out into the field, or do you only test them when they come back defective or broken?
It depends. Some testing is quite expensive. Like they're tested during design, obviously. They'll build them up and they'll test them. But when you actually build a gearbox like this, a lot of companies will pay extra for them to be load tested before they go into service. It's pretty expensive, like a load test will cost probably around 15,000 Australian dollars. So a lot of customers, like the lower end agricultural customers won't do it, but big mining companies will, because their biggest concern is reliability. If a machine goes down, it's going to cost them $1 million every hour. So they don't want them to go down. So yeah, we test gearboxes in complete. And so we hook them up to motors and we just drive them as hard as we can to prove that they're fit for service.
All Grayson has asked, what aspects of your job do you like the most versus maybe what you dislike the most? And there's some follow-up questions, but we'll start with that one.
Okay. So I really enjoy being given like custom problems. So it happens a lot where a customer has a application where our standard catalog products won't cut it, and then you kind of have to start designing things like from the ground up. I really, really enjoy that particular process. I think it's fun. It can be challenging. It can be a bit frustrating, especially if what the customer wants isn't possible. It can get a bit awkward. But it is a process I do enjoy. I intensely dislike any kind of project management at all, and I do everything I can to avoid it. I really, really don't like it. But it's kind of because of my job is, a little bit more senior, I guess. Well, I don't know, senior is the right word, but than a design engineer, I do have to go into project management more than I would like, and I don't like it.
I would think project management gives you more opportunities to see the full life cycle of a product. Is there something in particular about project management that you really don't like, or am I just wrong in that regard?
No, you're absolutely right, and it's also that's another good point. Project engineers or project managers, it's a really good job for engineering graduates, especially if you don't want to do like math and design and stuff. A lot of people don't, but project management is good for reasons you just said. The reason I don't like it is because it doesn't suit my personality. I get really stressed about it. When something goes wrong, I can't just go home and forget about it. And at the end of the day, it stays in my head and like stresses me out. And so for that reason is why I don't like it. It's a very high stress job, and I think you need a particular personality type to enjoy it.
Okay. And some follow-up questions from Grayson were, do you have any plans for the future, such as maybe changing companies or industries? And have you been with Falk the whole time? I think you mentioned a few companies, so I'm not sure if whole time is referring to a specific period.
Yeah, so I worked for 3 companies. This one here, Falk, an American one. I work for this company here, the pharmaceutical tool makers there in Ireland. And right now I work for this one, SEW. So because I've named my employer, I'm not going to tell you if I'm planning on moving companies. The answer is no. I really enjoy what I do right now. I don't really have any long-term plans. I kind of, right now I kind of am where I wanted to be 5 years ago. If you like, how to word that? So like, that question you get asked, where do you want to be in 5 years? So 5 years ago, I would have said that I wanted to be where I actually am right now. So I'm pretty happy. There's always room to grow. There's always room to move up, and there's always room to make more money. But for right now, I'm pretty happy where I am. No real long-term plans to move. The employer that I work for right now is, I think, the best employer for me that's available in Australia. So I'm just taking it one day at a time, I guess.
Well, that sounds wonderful. I think we're all very happy for you and glad to hear that. I know that we can all only hope to one day feel that way. So maybe not specifically in Australia. It sounds nice otherwise. Let's see. Skunka Munka asks, what's the demand for electrical engineers in the Australian iron ore industry? I know the iron ore companies use autonomous vehicles. What other electrification is imbued in the process? So I guess maybe you could talk a little bit about any coworkers that you might deal with who.
Yeah, so there's a lot. Geez, electrical engineers. There's probably more jobs for electrical engineers than there is for mechanical. I don't know. Maybe that's not true. There is a lot though. Power systems and power distribution is obviously huge. I mean, when I'm talking about megawatts of power being transferred, there's a huge amount of design the electrical engineering teams generally are larger in terms of staff than the mechanical teams. These mine sites are big enough that each one will have its own power plant powering it. So there's jobs in the power plant, there's jobs in the distribution, the design of distribution. There's process control systems. They have these huge big rooms, and they're just full of VSDs and other control systems that are connected up to these magic electric boxes that control things. I don't really understand it, if I'm being honest. As far as I'm concerned, the electricity goes into this motor, and then spinny stuff comes out, and that's all I really care about. But yeah, there are massive amounts of jobs for electrical engineers. As you mentioned, Rio Tinto have recently, they're one of the biggest mining companies in the world and the second biggest in Australia. They recently switched all their trucks over to fully autonomous, driverless vehicles. So yeah, there's a big scope there. The trains are also autonomous now as well, so they require some pretty sophisticated control systems. So yeah, there's an enormous amount of work for electrical engineers in basically any aspect you can think of, all the way from process controls and to large scale distribution and power plants.
All right, that's fantastic news for Skunk. Grayson asked, have you found the design process in your industry to be sort of algorithmic or very diverse based on each project? I think you mentioned that you had your own spreadsheets earlier. Would you say that that you are able to reuse a lot of those spreadsheets? Do you find that the tools in your proprietary software to be repetitive at times, or is everything an adventure for you?
Well, it's a good question. I'm not really sure how to answer it. So gears are an old technology. They've been around for a long, long time, and they've kind of been optimized to death, right? Like they're finished essentially. The theory behind them is done. The books have been written. There's not really a lot of room for innovation. I mean, there is innovation, don't get me wrong, but you're talking about getting 0.5% more performance or more lifetime out of a gear. Like we're down to that sort of scales of things. So yeah, it is quite repetitive. You will do the same calculations all day, every day, the same ones. But that doesn't mean it's not satisfying. You will do the same calculations, but each specific problem will have its own challenge that's unique to that job, even though the calculations themselves are the same. So yeah, while your workflow might be quite similar, you do get quite a diverse workflow, even though the specifics are very similar. I hope that answers it all right.
Yeah, it sounded nice to me. Let's see. Seuss asked, was tooling or assembly work easier than your large-scale projects? Was the tolerance level significantly different?
Yeah, it can be. It can't be, like, say, these tools here. So I think the design of these was more challenging in some ways and less challenging in others. These tools here, you need to design these very much in mind for how they're going to be made. It's massively important that you design these so they can be made as fast as possible and as accurately as possible. And so a lot of thought goes into the manufacturing process itself. Whereas with gearboxes like this, that's not as important. Like machining time isn't really a massive concern for bespoke projects. It is for catalog products, but I don't design catalog products. So I didn't like designing these tools. Not as much as I enjoyed these ones, these bigger ones. So I preferred the bigger projects, but I wouldn't say one is easier or harder than the others. Gears themselves are incredibly precise. I mean, you're talking they'll get into precision levels of 25 micron or less, which is pretty similar to these. But the production process for gears is much more standardized. They're made in like the one way, and that's just the way that it is. But these tools here, these have all kinds of different ways that you can make them. So yeah, I don't know. I don't think one is more enjoyable or one is harder than the other, but they do. I have a preference, which is for gears, but I did also enjoy my time learning about how tools are made.
All right. See, we have a question from, and I'm sorry if this is not how you pronounce it, but Veit, V-E-I-D-T. They say, I am a chemical engineering student from South America. Would it be possible for me to get an entry-level job somewhere in Australia, or should I aim to get experience in my country before applying to overseas jobs? I know you started by talking, this is me speaking now, I know you started by talking about how you basically moved straight to Australia to find some work, but those were certainly different circumstances. Do you think something like that could still happen today?
Yeah, it could. I'll clarify a point here though. What I did was stupid, and I wouldn't advise anyone else to do it. It's not a great idea to do that. I did it out of desperation. Like there was nothing in Ireland. And I kind of went to Australia with the mind of like, maybe I'll get a job, and if I don't, then I'll just have a nice holiday and I'll go home. That was my thinking behind it. In terms of specifically for chemical engineering, there are chemical engineering jobs in Australia, but they can be very competitive. There are more chemical engineers than there are jobs. If you work in chemical engineering, you're probably going to be working for the gold or the aluminium industry. I would probably say you should get 2 years experience and then try to move. Australian companies are very hesitant to hire people who don't have Australian experience. And they're even more hesitant to hire people who are not Australian, who don't have any experience. So I would say, yes, get maybe 2-3 years under your belt and then try and move. But always keep your head to the ground anyway. Like you might find an opportunity with, if you just keep looking all the time, you might find some sort of opportunity where you can get a job.
Speaking of competition, Seuss asked, do you ever complete projects for the aerospace industry?
No, we don't do aerospace. I mean, there are gear companies that do stuff just for aerospace. Helicopters have some pretty intense requirements for gears, but there are companies that make gears just for that because they require probably a little bit more precision because weight is more of a concern. Like in everything I design, weight is not a concern at all. But in aerospace, it obviously is hugely. So there are other companies that specialize in that. So no, I've never done anything for aerospace. And my company has done stuff for defense. I think they've done stuff for tanks, but not aerospace.
Okay. Let's see. Skunka Munka came back with, can you contrast a small firm, say less than 10 people, versus a big company, say 100 more or more? Yep. Do you feel valued? Do you get lost in the corporate hierarchy?
Yeah. Yes, you do. I tend to avoid large companies where I can. I don't like working for them. SEW is an enormous company. Globally speaking, there's about 17,000 employees. And then in Australia, they have around 300 or so. And then my department is around, 50-ish, say. And the departments are quite separated. So like I'll almost never speak to anyone in the electrical department. It's very rare that I will. So in that sense, it feels like it's a small company, even though it's not. And that suits me. This company here, even though they were, Prodico, even though they are a family-owned, smallish company, and they had a lot of designers. Like there was they had a whole like floor, and it was maybe 30 or 40 designers all kind of sitting at cubicles, just designing all the live long day. You do start to feel lost, and you can feel devalued. It can be hard to move up, and because you might feel like you're being ignored, especially for people who aren't very social. Some people don't like to talk a lot, or they just kind of go to their desk and they just kind of quietly do the work. I found that in many companies, those types of people in large companies tend to get ignored, and they they get passed over for promotions or for opportunities simply because they're just not good at making themselves heard, and they get lost in the crowd. So for those types of people, I would definitely recommend smaller companies. In smaller companies too, it's not a general rule, but they can pay worse. They can be a bit more stingy because for them, $1,000 is a lot of money, but for like Raytheon, $1,000 is pocket change. So you can be nickel and dimed a lot in smaller companies, but none of those rules are really like 100% true all of the time. It's kind of down to preference. You'll just see it as you get into industry. You'll know what you prefer. You'll just learn it. You'll naturally gravitate towards the type of business that you prefer. So if you're coming out of university and you're wondering, oh, should I work for a small company? Should I work for a big company? I wouldn't worry about it too much. Just get a job, and then you'll learn what's good for you and what's not.
All right. I think this is the last question, so I just want to say real quick, if this is not your question and I missed it, then please ask again, or reply to your question and ping me. Make sure I see that. If you have any more questions, please go ahead and ask in the next few moments here. With that being said, Laz, I think the last question is there a large demand for computer engineers in your industry? Have you seen them often throughout your work?
No is the answer. I work in big dumb machines that require dumb control. Computer engineers probably not really that big in mining. Process control uses computer engineers, but I think a lot of that is offshored to companies that make software specifically for that we don't really have any involvement with. There's not a huge industry in IT in this country anyway, so even if they wanted to do that stuff onshore, I don't think Australia has the capability to do it. There are some, but not many, I don't think. I'm not that confident in that answer. I don't really know, if I'm being honest.
Yeah, I think that's fair. All right. Well, I don't see any other questions. Laz, do you have any final remarks or anything you might have thought of throughout this Q&A that you'd like to talk a little bit more about?
No, not right now. I think I've covered everything.
All right. Well, again, thank you very much for your presentation, and thank you for staying here for so long, answering all of our questions. It's been a pleasure to listen to you, not just because everyone seems to love your voice, but because you seem very knowledgeable with what you do, and you seem like you've had a wide array of roles in a relatively few amounts of positions that you've had. So it's been a pleasure to have you here. And for everyone else, thank you for joining. Thank you for asking your questions. If you have any further questions, or if you think of anything else after this presentation is finished, feel free to, I suppose, ask it here, and maybe we can just chat about it afterwards. If you enjoyed this presentation, or if you learned something new, again, please share our Discord link that you can find in the large meeting room, and I will copy and paste that again shortly. Let's see. Yeah, like, subscribe, and follow. Again, this was recorded, and we will be posting a video to our YouTube channel. When we do so, we will share the link with everyone in the announcements channel, so be sure to look out for that. If you would like to just revisit this presentation, if you feel like maybe you missed a part of it, if you came in late, if you had to leave early, that's fine. Again, it'll be posted so that everyone can review it, watch it at your leisure, share it with your friends, convince your mom you chose the right field of engineering, even though it's 6 months after graduation and you're still looking. You know, whatever you need it for. All right. With that, thank you again, everyone. And I think we will stop recording here and we can kind of just leave, relax, hang out here if you like. I think most of you are muted, so, well, you know, you can just kind of listen. But with that, I'm going to stop talking.
That was awesome.